So now you can see 250 becomes a root node, right? 250 becomes the root node. Now again we will check whether is it satisfying the property of a min heap or not, and obviously not, because 250 is not smaller than 200. So what we are going to do, first we will compare 250 with 265. So 250 is already smaller than 265, but 250 is not smaller than 200. So 200 will move up and 250 will move down. Right, so 250 becomes our child, that was our parent node, and at this level 250 is already smaller than 260, 265 is smaller than, so basically 200 is the root node. And now what we are going to do, we are going to delete our 200, and 200 would be placed over here. Now the array is going to be sorted, right? So now what we are going to do, we are going to replace our last element with our root node. So 260 becomes a root node, and on a left we have 265, on a right we have 250, on a left of 265 we have 360, on a right of 265 we have 350, and on a left of 250 we have 260, right? So this is the tree we have got after converting the min heap, or you can say the calling min heap function. Now what we are going to do, we are going to again check whether the parent node is smaller. So 260 is smaller than 265, but it's not smaller than 250. So 250 will move up and 260 will go down. Now 260 and 260 both are the same. So and at this level 260 is less than 360, and 265 is less than 350. So what we are going to do, we are going to delete 250. So 250 would be placed over here, right? So the next element would be take place as a root node. So 260 becomes a root node. 260 becomes a root node, and on a left of 260 we have 265, on a right of 260 we have 260, right? 265, on a left of 265 we have 360, on a right of 265 we have 350, and that's it. So this is the tree we have got, and as you can see, this node has been eliminated, this node has been deleted, right? So after again checking level by level, we can see 260 is smaller than its left child, or if we compare this node with the right child, both are the same, but we cannot swap because both are the same, right? So 260 can be deleted. So our array would be like this, our new array. First element is 75, second element is 100, third element is 150, next 165 and 185, and 200, 250, and the next element is 260. 260 would be placed here, and last element is basically 350. So 350 will take place as a root node. So 350 becomes the root node. Left child would be 265, right child would be 260, and 265 left of a 265 is 360, and right is basically already moved as a root node. So you will observe after 265, after 260 we will have 265, uh, 265, then we can get 350, and then we can get 360. So the array is basically sorted in this way, right? The array is sorting in ascending order. So you can see we perform delete function on each level. We perform deleting root node. We perform deletion on a root node, and we replace our last element with a root node. So by doing these two steps on each level, we can get a sorted data. We can arrange our array. We can arrange our data elements by using heap sort algorithm. And as you can see, we have used a min heap problem or a min heap situation in which we've got ascending order, we've got sorted data in from smaller to bigger values. But when we will use a max heap, we will get a descending order. And same thing we will perform in max heap, and that is to delete the root node and replace it with the last element that we will have in a problem. And by replacing the last element with a root node, our heap would be changed. So to make a heap in a max or a min heap, we have to again traverse, or we have to call the again main function or a max function accordingly, right? Obviously, if we have a max function, then definitely we've got descending order, and if we have min heap, then definitely we will get ascending order. So by deleting the nodes, as I told you in previous lectures, because our objective was to sorting data, but how we can sort the data by deleting the root nodes from the min heap or a max heap, and by replacing the last elements with a root node, we can get the sorted data. So this is all about today's lecture, in which you've learned that how we can the sorted elements, sorted data from min or max. So min and max both are the properties of a heap sort algorithm. And first of all, we discover the arrays. We represent the arrays. Obviously, these are the data structures, and for the data structure, we need to represent our data. We need to store our data in an architecture, in a structure that is array. And for the array representation, we should have an order. We should have the representation of our problem that can be represented as an array. So we used array, and we converted our heap into max heap and into min heap. And after converting the heap, we perform delete function. And how we perform delete function? We replace our deleted node with our last node. So this is the method that how we can get the sorted data by using heap sort algorithm. And delete is one of the function of a heap sort algorithm. So thank you so much. If you have any question, you can ask to me.